Tease a red Goliath star anticipating you. Put it where the sun is, and it would release energy up to the circle of Jupiter. It's gigantic, totally touchy, and going to detonate. These effects are among the most essential launches of radio energy in the whole universe, conveying more energy than a billion suns. Are you ready for what will occur? Terrifying minimal creatures squeeze a huge red, very monster star. One of the nearest stars to Earth has, as a matter of fact, gone through a striking diminishing that has stood out enough to be noticed. Mixed opinions, by and large, have arisen. This reduction has prompted hypotheses among stargazers and the general public about its true potential repercussions. A couple of experts believe the peculiar behavior could be a harbinger of an endless impact, a dramatic event that happens when a star weakens its atomic fuel and collapses under its own weight, inciting an epic effect. Such an event raises concerns not just among established researchers but also among the general populace, as it brings up questions about the potential impact on our own planet. Bug juice is an unmistakable piece of the brilliant body, which is easily recognizable in the night sky due to its undeniable shape and brilliant stars. Moreover, referred to as Alpha Orionis, it holds the title of the brightest and greatest star in this eminent body. Consistent data gathered by NASA's Hubble Space Telescope, alongside observations from various observatories, have shown that bug juice experienced a colossal mass ejection in 2019. This event is intriguing for a star of its kind and has piqued the interest of stargazers. While coronal mass ejections are a regular event in our own sun, the exceptional event found in bug juice adds an intriguing layer to how we interpret divine life cycles and the dynamics of massive stars. The distance to bug juice remains a subject of discussion among stargazers. Some estimates suggest it is farther away, while others propose it might be as close as 724 light-years from Earth. Precisely determining the distances of red giant stars like bug juice is a complex challenge due to their vast distances and unique properties. Bug juice stands out as one of the brightest stars visible in our night sky, showing a brilliance many times greater than that of the sun. However, this vast brilliance comes at a significant cost. Bug juice consumes its atomic fuel at an accelerated rate, racing towards the inevitable end of its stellar life. Ultimately, the star will deplete its fuel supply, instigating a profound collapse under its own gravitational pull, possibly resulting in a colossal impact that could give birth to a neutron star or even a black hole. Should our current astrophysical theories prove accurate, this raises a significant question. Does bug juice represent a risk to Earth? If a tremendous impact were to occur a few light-years from our planet, the consequences could be devastating. The impact of a supernova can release an extraordinary amount of light, potentially matching that of an entire galaxy. Thus, whether bug juice is relatively close, like the star Alpha Centauri, or farther away, the effects of its massive impact could be enormous and far-reaching. Amazingly, the last recorded supernova in our own universe occurred in 1604. Humanity has not been able to observe such an event locally since then. However, an extraordinary supernova occurred in 1987 in the Large Magellanic Cloud, located 169,000 light-years away. While that event had significant effects, it posed no imminent threat to Earth, serving as a reminder of the scale and potential impact of such cosmic events. The idea of a risk zone associated with a typical supernova is fascinating and could have serious repercussions for life on Earth. If a supernova were to occur nearby, it is critical to understand that in the grand celestial timeline, supernovae are relatively small events compared to gamma-ray bursts, which are vastly more powerful and represent a different kind of threat. Gamma-ray bursts can have devastating effects, capable of crushing biospheres and saturating planets with harmful radiation. For example, a specific type of galactic burst could lead to the destruction of a planet's ozone layer, leaving it vulnerable to the harsh radiation of the universe long after the impact has occurred. This possibility was highlighted in a recent study that presented new potential risks associated with massive stars that end their lives in an explosive manner. When giant stars detonate in a supernova, they can reach some of the brightest luminosities known in the universe. In fact, the brightness of a single supernova can surpass the combined brightness of millions of stars. This raises the question, what might the consequences be if bug juice were to undergo such an impact? If a supernova were to occur, Bug juice would become the second brightest object in our sky after the sun amazingly. Despite the distance separating it from us, bug juice, shining more brightly than a full moon, would become visible. During daylight hours, the sheer power of the explosion would result in a display so astonishing that shadows would be cast even in complete darkness. Such a scene would both amaze and terrify, showcasing the raw power of cosmic events. While the visible light produced by a supernova is indeed immense, it is only part of the total energy released during such an event. Although high levels of visible light can cause temporary blindness, the greater concern lies in the high-energy radiation released alongside the visible light. This radiation often manifests as X-rays and gamma rays, which can have wide-ranging effects. One of the most significant dangers posed by this high-energy radiation is its ability to catalyze the depletion of oxygen from the ozone layer, which protects our planet from harmful solar radiation. Without a healthy ozone layer, life on Earth's surface would be exposed to extreme ultraviolet radiation from the sun, potentially leading to mass extinction events. In the aftermath of a supernova, various dangers arise over time. In the initial minutes following the explosion, the intense radiation presents immediate threats. However, over time, massive beams of light particles traveling at near-light speeds begin to move through the solar system. These powerful beams can break apart ozone layers and blanket the Earth's surface with harmful radiation, exacerbating the dangers posed by the initial explosion. Furthermore, supernova beams carry a significant portion of the total energy produced by the cosmic impact, and their long-term effects can persist for years. Evidence suggests that such events may have impacted Earth in the past. For instance, elevated levels of iron-60, a radioactive isotope created in supernovae, have been found in ocean floor sediments and lunar regolith. This finding suggests that Earth may have been influenced by supernova ejecta in recent geological history, perhaps within the last few million years. Astronomers have already concluded that there are no nearby supernova candidates that pose an imminent danger to life on Earth, based on our current understanding of the risks associated with gamma rays and supernovae. However, ongoing research has uncovered additional potential risks associated with specific types of supernovae. These supernovae can produce long-range lethal radiation that poses a greater threat to planets like our own. The mechanism behind this involves a star nearing the end of its life, surrounded by a massive disk of material. When the supernova occurs, a shock wave is created, striking this disk and causing it to become extremely hot. This, in turn, generates a significant amount of high-energy X-ray radiation that can travel vast distances through space. The brightest X-ray cosmic blasts have the potential to deplete a planet's ozone layer by as much as 50%, creating conditions that could trigger an extinction event within a range of around 150 light-years. Fortunately, no candidate X-ray supernovae have been identified in Earth's immediate vicinity. However, this research has led to new insights into the concept of the habitable zone in space, the region within galaxies where conditions are optimal for life. The findings suggest that this habitable zone may be subject to additional constraints. Specifically, the outer regions of galaxies may not have sufficient star formation activity to create the elements necessary for the development of rocky planets. Meanwhile, the inner regions, where stars form and die at a faster rate, present their own risks. Frequent supernovae in these regions can illuminate the surrounding space, increasing the dangers for any potential life that might exist there. New research suggests that the inner boundary of the cosmic habitable zone is likely located farther from the galactic center than previously thought, reshaping our understanding of where life might potentially flourish. So, what might the terrifying bug juice supernova look like from Earth? While Earth's biosphere would likely remain unaffected, the spectacle itself would be impossible to ignore. According to scientists, bug juice would continue to shine brightly for more than 90 days following its explosion, reaching a brightness nearly equivalent to about half that of the moon on several occasions, and much fainter than a full moon. Essentially, it would appear as a bright point above, serving as a beacon visible even during the day. Its striking brilliance would captivate anyone who gazed at it, casting colored shadows at night. This celestial event would undoubtedly be a source of fascination for everyone on Earth, as the massive explosion remained visible to the naked eye for months. Its remnants would slowly fade as researchers continued to study bug juice, uncovering more about the life cycle of massive stars and the processes that lead to their dramatic endings. Understanding these colossal phenomena is crucial for gaining insights into the evolution of our universe and the creation of elements during a supernova. Beyond the light produced during these events, a wide range of heavy elements, such as gold, silver, and uranium, are formed under the intense heat and pressure of the explosion. This process, known as nucleosynthesis, plays a critical role in enriching the interstellar medium with the building blocks necessary for future star and planet formation. Interestingly, the remnants of a supernova, known as a supernova remnant, can transform into a stellar nursery where new stars are born from the dust and gas expelled during the explosion. This cyclical process highlights the interconnectedness of cosmic events and demonstrates how the death of one star can lead to the birth of others. Scientists have identified several supernova remnants that are still forming new stars thousands of years after the initial explosion, showcasing the dynamic nature of the universe. Another intriguing aspect of studying supernovae is their role as cosmic distance markers. Astronomers use Type Ia supernovae, explosions from white dwarf stars that reach a peak brightness, as standard candles for measuring distances in the universe. These standard candles have been instrumental in understanding the expansion of the universe and even discovering the mysterious force known as dark energy, which is driving the universe's accelerated growth. In conclusion, while the prospect of bug juice exploding in a supernova is both awe-inspiring and intimidating, it serves as a reminder of the vastness and complexity of the universe. The study of such events not only deepens our understanding of the cosmos, but also underscores the delicate balance that sustains life on Earth.